Hey, Jake, do you have a particular one that you would like for me to go over? Is there like an assignment or worksheet that Miss Wynn has assigned?
Yes, ma'am. Let me check real quick. It was on my today's assignment. Let me try to find the problems.
Okay.
So yeah, it's on page 124.
124.
Yes, ma'am. And it's just 21 to 33, but all the odd problems.
21 to 33. Odd.
Yes,
All
ma'am.
right. Well, I'm gonna pull the book up
All righty.
and then we'll start working.
Yes, ma'am. I just don't understand factoring. That's just the one thing I'm not the best at.
Oh, yeah, it's definitely that can be. And this two is that 2.5?
Yes, ma'am.
Okay. Yeah. It's definitely something that it comes with time and it takes a good bit of practice. That's for sure.
Yes.
But you will get better at it, I promise, over time.
Yes,
It
ma'am.
does it does take a minute though. Let's see, 124, verse 21 through 33. Okay. And on these are kind of special anyway, because you have to begin with your division first, because you have to get that x minus 6. Well, it would help if I shared the book with you, wouldn't it?
Yes, ma'am. It's all right.
I apologize.
It's okay.
Um, on these, you definitely need to use either long division or synthetic division, whichever one you prefer, to get
Okay.
that first 0 out. What is your preference?
I think I honestly I can work with either. I mean, we can try synthetic division.
Okay. All right. I just want to make sure. Usually students have a favorite. Last year my class was pretty split. I had some that really, really liked like the regular long division, and then I had some that just preferred uh, the synthetic. So we're just going to go with synthetic, and I need to have my book on 2 computers so that when I go to my blank screen where I do my work, that I can.
Okay.
I literally had a over 2 hour math lab with Algebra 1, and that's why I'm running late, and I apologize for any inconvenience that had on you.
It's okay.
So the problem is f of x equals x cubed minus 10x squared plus 19x plus 30. And it says we're supposed to factor it completely, and it gives us one factor of being the x minus 6. So using synthetic division, I'm going to put my 6 over here and then set the rest of my problem up by taking each of the coefficients, making sure that I don't need any placeholders.
Okay.
So I see there's an x to a third followed by x squared followed by x. So I don't need a placeholder. So I'm going to take the leading coefficient of all of these. That's a 1, a negative 10, a 19, and a 30.
Okay.
And I'm going to bring down my first coefficient, if you will. Just bring down my first number. And then I'm going to multiply 1 times 6 is 6. And I'll put that here. And technically, I'm adding as I go along. But obviously, since this is a negative and that's a positive, I'm going to find the difference and give the sign of the higher one.
Okay.
And then I'm going to multiply again. Negative 24 times 6. I mean, negative 4 times 6 is negative 24. So once again, I've got a negative and a positive. So I'll find the difference and give the sign of the higher, which that's negative 5. And negative 5 times 6 is negative 30. And praise God, we did everything right. And we got a remainder of, that came down to be a 0, which we would hope, because if this were not the case, then this would not really be a factor. So yay. So we know, that's definitely true. That's a good thing. So now what we're going to do is take what's remaining.
Okay.
And put our terms with it. And what we know is you're going to start one term down from the highest degree that you have. So that would be x squared. And the coefficient is going to be 1. So we have x squared minus 4x minus 5. And we're going to factor this. And this is the part that you said is the most fun for you, right?
Yes. Yes.
Okay, so what we're looking for is two factors that when multiplied together, so I'm going to put an X there for multiplication, if you will, not like an X as a coordinate, that when you add them, I'm going to put a plus over here, add or subtract or combine them, that you're going to get a negative 4. So you'll think of the factors of 5. You've got plus or minus 5 and plus and minus 1. So that would give you a negative 5, or oops, my bad. If you multiplied negative 5 times negative 5, you'd get a positive 5. But if I multiply a negative 5 and a negative 1 and a positive 1, I would get a negative 5. At the same token, if I combined a negative 5 with a positive 1, I would get a negative 4. And that's what I'm looking for.
Okay.
Does that make sense?
I think so. Yes, ma'am. Yeah, you're just adding. Yes.
So I've got x minus 5 because I'm going to use them now in my factors. X plus 1. So my fully factored polynomial, including the given, is x minus 6. That's the given one, okay?
Okay.
And then we used synthetic division, and then we used what we know about good old factoring to get the other two. And now this is fully factored.
Okay. Alrighty.
All right, let's do a couple more. And I've got a different way of factoring that I don't know if it'll help or make it worse. I don't know. We'll try. Do you want to try a couple different ways?
We can try it. Yes, ma'am.
All right. Hopefully, I had somebody in my class that one of the videos showed a gentleman making that little T chart to come up with all the different factors of something, and then made the factors on one side and then the combos on the other, and that helped that particular person. So it's with factoring, Jake, it's doing a lot of it and finding that technique that kind of works for you. That's really, what needs to happen. Does that make sense?
I think so. Yes, ma'am.
Because it is one of the trickier parts, I think, of algebra.
Okay.
All right, 23. And you are not alone, my friend. Not alone at all.
Yes, ma'am.
There's many in your camp.
Yes, ma'am. Thank you.
X cubed minus 2x squared minus 40x minus 64. And then the factor given is x minus 8. So I'm going to set up my synthetic division. Are you good with staying with that same kind?
Yes, ma'am.
Okay. So I've got 8. And then once again, I'm just going to double check to make sure I don't need any placeholders. But I see that I've got an x cubed, an x squared, an x. So everything is in descending order with no skips. So I don't need a placeholder.
Okay.
So I've got the coefficient on the first one is a 1. The coefficient on the second one, that 2x squared, is a 2, followed by a negative 40, followed by a negative 64. And I'm going to bring my first term down, and then I'm going to begin multiplying. 1 times 8 is 8. Typically, once again, I want to remind you that this is where you would add, but since we have a positive and a negative, we're going to find the difference and give the sign of the higher one, which in this case is 6.
Mm-hmm.
And then 6 times 8 is 48. And negative 40 with a positive 48, find the difference and give the sign of the higher one. And then 8 times 8 is 64. So that gives us a 0, confirming that x minus 8 is indeed a factor. And now what we'll do is apply our answers to the appropriate terms. Okay. So that's going to be x squared, because you just go down one term from this one. So we've got x squared plus 6x plus 8. So once again, we're looking for 2 factors of 8 that when we multiply them, multiplied gives you 8, but when you add them, you get 6. And the factors of 8 are 8 and 1 and 4 and 2. When we add 8 and 1, we get a 9, so that doesn't work. And when we add 4 and 2, that gives us 6. So that does work because that gives us this piece right here.
Okay.
All right. So this is the multiply side. This is the add side. And the add goes in the middle. Some people like to write it like this. And write their factors completely out. Because remember, when you FOIL, that's that middle part. So they'll then see how we did those 2 factors, that 4 and that 2. They'll do it like this. And then they factor out an x from here. And they get x plus 2. And then they'll factor out what would they factor out there? A 2. Oh, no. And they would be left, no. Oops, my bad. I wrote something wrong.
All right.
This should have been an 8, Angel. I'm so sorry, love.
Okay.
So that would give you this, which then breaks down to x plus 4. And maybe had I not messed that up, this might have made more sense to you. I don't know. Which way do you like it best?
I think I like the first way.
Okay.
Other than, I think it's more straightforward.
Okay. All right. Did this little table help?
Yes, it did. Yes, ma'am.
Okay, good. All right. So the fully factored, the 3 factors of this polynomial are x minus 8. That's the given. Plus the 2 that we got figured out, which was x plus 4 and x plus 2.
Okay.
All right. Let's, I want to definitely do number 25. Are you good with going on, or you?
Let's see. Which number?
25?
Wait, yep, I'm ready. We can move on.
Okay. All right. Because it's a little different. And I also want to point out, And you students know a lot more about the books than probably we teachers sometimes. I want to also point out, notice that number 25 has a circle around it.
Oh yes, I remember. Yeah, it's the what is it called?
It's in the additional answers, and it actually shows you exactly how to work it out.
Yes, ma'am.
Okay, I did want to make sure that you did know that. So if you ever need extra help, that's a good place to go to.
Yes, ma'am. I knew that. Yes, ma'am.
Okay, good. I'm so glad. Like I say, you students are pretty savvy when it comes to all this stuff.
Thank you.
But I like to make sure that you guys know.
Yes, ma'am.
F of x equals x cubed plus 2x squared minus 51x plus 108. And then we're given a factor of x plus 9. So we're going to set up our synthetic division. And you'll notice this time the factor has a plus sign in it instead of a minus. Okay, so that means over here in our synthetic division, you take the opposite. And you're going to use a -9 there.
Okay.
So we've actually been using the opposite every time, but I didn't really point it out because it was just like, because it was x minus 6, you use a +6. That was number 21. And in number 23, it was x minus 8, and we just used an 8. So you're kind of taking the opposite, if you will. Okay? All right. So once again, the first thing that we want to double check after we've set up the sidebar with our factor on the side, we want to double check and make sure that we don't need to have any placeholders. And everything looks to be in order 3, 2, 1, basically. So we don't have any placeholders. So we'll set our synthetic division up by taking each of the leading coefficients of our terms. So that'll be a 1, a 2, a -51, and then a 108.
Okay.
And we'll bring down our first number, which is the 1. And we multiply 1 times -9.
-9.
Yep, good job. And then we are going to combine those two. And once again, it's typically adding, but so far we've had it to where we're subtracting. So I don't ever want that to throw you a curveball later. But so far, because we've had a positive and negative, we're still finding the difference and given the sign of the higher one. And now we have a -7 and -9. That's going to be a +63. And the difference between those two, that's going to give us a +8, right? No. 12.
12. Okay.
A +12. Okay. And then 12 times -9 is -108, which that makes it a 0, confirming that x plus 9 is in fact a factor of that polynomial. Right. So now what we'll do is set up our answer x squared minus 7x plus 12. So we'll set up the factors of 12, multiplying here, adding here, and we've got 12 and 1.
And they have to add up to -7. That's what we're doing.
Yes, okay. Good job. 6 and 2. Praise the Lord. That is it. Okay. So 12 and 1, that's 13. That doesn't work.
That doesn't work.
6 and 2 is going to give us an 8. That doesn't work. 4 and 3 do add up to be 7, but we need it to be negative.
Negative, so negative.
So if we did -4 and -3, that would give us a -7. And if we multiplied a -4 with a -3, we would get a +12 because two negatives times one another is a positive.
Okay, I see that.
Okay, so x and then you'll do minus 4 because that's your factor, and x minus 3.
Okay.
Okay?
Yes, ma'am. And like x plus 9 on the side, too?
Oh, yes, sir. Yes, sir. Good job. Way to remember. Good job. So all 3 factors of that polynomial are there.
Okay. All right.
Okay, do you want to skip down and look at number 29?
Can, yes, ma'am.
Or do you want to keep working through these? You're the boss.
Yeah, I know.
I don't think,
I
has
could do
anybody else shown up?
2 others are in.
Oh, 2 others?
Yes.
Oh, Garrett and Bella.
I was here for 31 and 33.
You need 31 and 33?
Yeah.
Okay. All right.
Yeah, I can just work on those with y'all then. I can just listen.
Okay. Are you okay with that? All right.
Yes, ma'am.
And all right. And Bella, I know your questions are going to be different, but if you want to take notes on this, because we're going to be we're a little bit behind you guys.
Oh, okay.
I mean, they're ahead of us, Bella.
Oh, okay.
So this is what you get to look forward to over the weekend.
Yay.
Because what is this, gentlemen? This is 2.5, right, guys?
5, yes, ma'am.
Okay. All right. 31. And much like the ones that we have been doing, 10x cubed minus 81x squared plus 71x plus 42. The given 0 is 7. So that means the factor really looks like x minus 7, but the given 0 is 7. Okay? So what you're going to do then is set it up synthetically. Just like we have been doing. Making sure, once again, that we don't have to have any placeholders. And we don't. It's 3, 2, 1. We're good. We bring down our first term, and 10 times 7 is 70. And negative 81 minus 70 is negative 11. Negative 11 times 7 is negative 77. And negative 77 minus 71 is a negative 6, and negative 6 times 7 is a negative 42, giving us a 0, once again confirming that 7 is, in fact, the 0. Then what we'll do, oh, and you're going to love this factoring, Jake. I know Garrett does. This is 10x squared minus 11x minus 6.
This is where I had trouble.
Yeah, I know. That's why I was like, I was kind of chuckling because I remember how much you love to do slide and divide with me. Jake,
Yes,
this
ma'am.
is another way to factor when the leading coefficient is not a 1. Okay?
All right.
All right. I call it slide and divide. So what we're going to do is we're going to slide down this 10 to that 6 for just a few minutes.
Okay.
Because believe it or not, I know it's not going to look that way right off the bat, but this is an easier way to go about it.
Okay.
And then I'm going to go over here to my little table that we've been doing, and my multiplication goes on this side, and my my adding or combining goes on that side. So I'm looking for something that gives me a negative 60 when I multiply it, and then a negative 11 when I am combining it. Okay. So that pretty much tells me that one of my factors is going to have to be negative and one of my factors is going to have to be positive. Okay?
Alrighty.
So we've got 60 and 1, and there's so many factors. We got 60 and 1, 30 and 2, and 20 and 3, and Lord Jesus, please help me. 12 and 5. I'm trying to think of them all.
15 and 4.
12 and 5. What am I leaving out, gentlemen? 10 and 6. 10 and 6. What else?
15 and 4.
15 and 4. And you're all over it because that's the one. Good job.
Yeah.
All right, because I can take a negative 15 and combine it with a 4, and I'm going to get that negative 11 that I'm looking for. So I'll go back over here and I'll have X.
Is that why it's a decimal? Because you move the decimal over to compensate for the sliding and divide?
I'm sorry?
The back of the book said the answers were decimal.
Oh, okay. Yes.
I don't think
and we're going to get to that part. I'm just showing you it's a little bit, this is a little bit easier than that decimal. Believe it or not. I know at first, the first appearance is that it isn't, but I promise it is. Okay, remember earlier when I said we're going to slide? Okay, so we've slid. We did our slide. Now we're going to do our divide because it's called slide and divide. Mm-hmm. What you're going to do is take that leading coefficient that we slid down and multiplied, and we're going to divide it by each of our factors.
Okay.
And what you're going to do is 15 over 10 actually reduces to 3 over 2. And this reduces to 2 over 5. And then to pretty it up a little bit more, or actually you can just take that if you want to. So your zeros are going to be it should be 7, 3 halves, which I think should be 1.5, and then a negative 2/5, or if it should be 0.4, negative 0.4. Is that correct?
I believe so.
These can also be written like this. But for a zero's sake, you can leave it like that.
Okay.
If it's looking for factors, this is a factor. These are the zeros. Did you look it up?
Me?
Garrett, yes, sir?
I guess that is the same. I mean, if it's a decimal, those might actually end up being the decimals that they gave us.
1.5?
Yeah, that's that. 1.5 and
negative 0.4.
Yeah.
Okay. Yeah, this is this, and this is that. Jake, you were just starting to like factoring. Did you just quit like factoring after that one?
Yes, ma'am. Mm-hmm.
I understand.
Yes, it's all right.
Did y'all get all that written down?
Yeah.
Hey, Garrett, is the next one just as pretty?
Yes.
Yay! I love it when y'all come on to Math Lab and really, really challenge me. It makes it so much more fun. And Bella, is this making you scared?
She's gone. I think she left.
She's gone. She left. She was like, no more. I'll email her. Y'all, we frightened her away.
Oops.
What number was the next one that I was going to work on? 33, is that correct?
Yes, 33.
And then, Jake, if you want me to go back and do a few more of those other ones because they were prettier and you want to end on a happier note, we always can do that too.
Okay. We can do 33 and 29. I think I can work on 27 by myself, but we'll play it out by ear.
Okay.
We move on to 33.
Is that okay? Yeah. Would one of you gentlemen mind reading it to me?
Number 33, I can. So f of x equals 2x cubed minus 10x squared minus 71x minus 9.
And what's the 0?
The 0 is 9.
9?
Yes, ma'am.
Okay.
Positive 9.
So I don't need to have any placeholders.
Right.
Oh, that was scary. And I'm going to write down my leading coefficients. That's my 0. I don't want to get it mixed up with my other. I'm going to bring down my first number. 2 times 9 is 18. And negative 10 plus 18 is a positive 8. 8 times 9 is 72. Negative 71 plus 72 is a positive 1. And 1 times 9 is a positive 9. Negative 9 and 9 is 0. So now I have 2x squared plus 8x plus 1. I'm going to slide and divide, which tells me I've got x squared plus 8x plus 2. Oh, that's ugly. We're going to have to use the quadratic formula. Are y'all excited?
Not really.
Slide and divide won't work. Just when you thought slide and divide was ugly, it all of a sudden became pretty because you had to compare it to the quadratic formula.
Exactly.
So my A is 2. Wow. My B is 8. And my C is 1. So the quadratic formula is the opposite of B plus or minus B squared minus 4AC all over 2A. So the opposite of B is negative 8 plus or minus B squared is 64 minus 4 times 2 times 1 all over 2 times 2. So negative 8 plus or minus 64 minus 8 all over 4. And then we've got negative 8 plus or minus 64 minus 8 is 56. Is that what y'all get?
Yes, ma'am.
Okay.
I think we're gonna run out of room.
I know, right? Okay, so 4 and 14. So what kind of crazy answer did you get in the back of the book for this one?
I didn't check that one.
Oh, okay.
I just kind of gave up. I was like, okay, none of this.
So you give up when they get ugly?
No, I was like, I'm gonna go to math lab and get the answer.
Garrett, I love you. You're great. All right. Well, here you are in math lab. All right. This is, I'm going to erase over here because you're right, Garrett. I did run out of room. But this is -8 plus or minus. This factored is going to be 4 times 14. Underneath the radical, 4 is a perfect square, so I'm going to bring her out, leave 14 in, and that's all going to be over 4, which then can be reduced. So that's going to be -4 plus or minus the square root of 14 all over 2. And that's 2 of your answers. And then that's the other 2 zeros that it's looking for. That's the answer to number 33.
The one circled, that's the only answer?
After all of that, Jake, I promise that's it.
Yes, ma'am.
No, there's got to be more.
No, I promise that's it. Wait a minute. Hold on. This right here. So what you guys will write down. Oh, look, it's a heart because we liked it so much. -4 plus or minus the square root of 14 over 2. But y'all better show all that work. I mean, come on, guys. If you have all of that all over your paper, how good are you going to feel about yourself?
I wrote a lot of it down.
Good.
Mm-hmm.
That was a humdinger, wasn't it?
It was. Oh.
Who assigns these problems, Mrs. Sparks and Mrs. Wynn? Who does that to children?
Who knows? Who honestly knows?
I promise y'all this is good for your brains. I promise.
Thank you, Miss Sparks.
You're most welcome, sweetheart. Is that how far y'all had to go?
Yeah.
The 33, that's how far we went.
Okay. All right, Jake, do you want to, you're welcome, Garrett. Have a lovely afternoon.
Bye, Miss Sparks.
Bye-bye. Hey, Jake, do you want to do 27 or 29, honey?
We can do, do you want to do them both?
Sure. I'm happy to help you, honey.
Okay.
You've never been to math lab. I want you to come back.
I usually when I did a lot in sophomore year, and then I had tutoring with Mr. Sickley, but we stopped doing Thursdays. So yeah, I'll just do it on Thursdays probably.
Okay. It's been kind of wonky for me.
Okay.
I'm trying very, very hard to have it in the morning so that it's consistent for you guys. But I had a dentist appointment today. And so that's been kind of weird. And here's the other thing I want to tell you. And if you wouldn't mind passing this on, I need to write an announcement in y'all's Google Classroom. But if for any reason, like I know you guys have Chem Lab on Tuesday.
Mm-hmm.
So on Tuesdays, if I do it in the morning and you guys know for sure there's something that you need me to go over, this is what I tell my students. Go ahead and email me the numbers that you want me to go over.
Mm-hmm.
And I don't ever say, oh, so-and-so asked me about this. I just say a student emailed me and asked that I would be sure and cover this in Math Lab. Mm-hmm. So I'm for sure covering this. And then I'll actually send you the link in an email of where I went over whatever problem you needed me to.
Okay.
Okay?
Yes, ma'am.
So, just let me know because, this is to help you guys.
Yes, ma'am.
All right. 27. We have f of x equals 2x cubed minus 15x squared plus 34x minus 21. And then we have a 0 of x minus 1. And just like I said before, you take the opposite, and the opposite of -1 is 1.
Okay.
And then you're going to double check to make sure you don't need placeholders, which we don't. We've got 3, 2, 1. So we're just going to take our leading coefficients of 2, negative 15, 34, and negative 21. You're going to bring down that first term and then start your multiplication process. 2 times 1 is 2. And then negative 15 and 2 is negative 13. Negative 13 and 1 is negative 13. And the difference between 34 and negative 13, that's 19. That's wrong. It's 21.
Oh.
It's been a long day.
Yeah, me too.
This is 21, and then 21 times 1 is a positive 21. So now we'll just add our variables to this. 2x squared minus 13x plus 21. And we're going to slide and divide on this one. So that's going to be x squared minus 13x plus 42.
Okay.
So we've got a positive 42 and a negative 13, which tells me that both of my factors are going to be negative.
Okay. So would it be, I think it's negative 6 and negative 7?
It is. We don't even have to do the table anymore. You're a genius. You don't even need me.
Thank you.
Awesome. Great. Now, the little sticky wicket
Yes.
we've done our slide, and now we have to do our divide.
Is this 27 or 29?
I'm sorry, love?
This is number 27, problem 27. Yeah, okay. All right.
Yes. Yes, it is.
We did slide.
I'm sorry. Did I say 29?
You said slide and divide. I thought we did that in 29, not 27.
Well, yes, we do. You might. Anytime your leading coefficient is not a 1, like this number right here, I'm going to circle it in a different color. Anytime that's not a 1, you can use slide and divide.
Okay.
All right?
All right.
But we did the slide, and now we have to do the divide. And the divide means, when we slid this 2 down, when we multiplied it here, now we have to take it back out. And when it's pretty, and it like 6 divided by 2 is a 3. So you can write that one down. This one right here is not as pretty. That's not going to be an even number. So when you're looking for factors, you just scoot him over here. So that becomes 2x minus 7. When you're looking for factors, this is what you do. So the answer here is going to be x minus 1, x minus 3, and 2x minus 7. Those are factors.
Okay.
In number 29, 31, and 33, you're looking for zeros.
Okay. Oh.
So you actually could have left this fraction the way it was.
Okay. All right. Yeah.
Because the zeros, just to clarify this with you, the zeros of this function are 1, because you take the opposite out, a 3, and a positive 7/12. Those are the zeros.
Okay.
And these are the factors. Can you kind of see the difference a little? You see the differences and the similarities?
I can, yes, ma'am.
Okay, great. Because this can be a troubling step for many students.
Okay.
Okay? So I just want to make sure if it asks for factors, it's looking for this animal.
Okay.
And if it asks for zeros, it's looking for this. just a number. And that's where it crosses the x-axis. Like if we were to graph this polynomial, this thing would circle all around that coordinate plane and cross the x-axis at all three of those points.
Okay.
That's why they're called zeros.
Alrighty.
Okay? I'm just trying to maybe make some, concept connections for you while we're in math lab and doing all this. Does it help a little?
I think it does. It's just tricky, honestly.
Yeah. You got all these things, all these hoops to jump through and trying to get it. Yeah. All right. And then we're going to do number 29.
Yes, ma'am.
And when we're good to go.
Yes, ma'am.
Praise the Lord. Do you have a lot of other homework today?
Today was I just got this and then I'll be done for the day. I had a pretty easy day in all my subjects.
Oh, good.
I'll have the afternoon off. Yes, ma'am.
That's nice.
Yes, ma'am.
Okay, number 29. Oops. Look, 27 reared its ugly head. We have x cubed minus negative 2x squared minus 21x minus 18. And it's giving us one of the zeros as negative 3. So that means we're going to put negative 3 because that means the factor, and I don't want this to throw you off, but the factor would look like that.
Okay.
Okay? But the 0 looks like that. So we're going to set up our bar here. We don't need a placeholder. Really haven't had to use a placeholder so far, and which has been good in a way, but I really want to drive the point home that you might need to sometime.
Okay.
1 times negative 3 is negative 3. Negative 2 and negative 3 is a negative 5. So there's our first time of really having to add. And negative 5 times negative 3 is a positive 15. Negative 21 combined with a 15 is a negative 6. And negative 6 and negative 3 is a positive 18. So now we've got x squared minus 5x minus 6. So we're looking for the two factors that multiply to give us a negative 6 that when we add them, so that means one's going to be positive and one's going to be negative, and the bigger one's going to have to be the negative one. So that would be negative 6 and 1.
Okay.
Which that would actually give us a negative 5. And this one was asking us for the zeros, the additional zeros. So the 0 means that you're going to solve
Okay.
and you can either solve it like that or you can take out the opposite.
Okay.
However, it's easier for you to think of it. But the 0 itself is 6 and negative 1.
All right.
Does that make sense to you or not really?
Look at it again.
These are zeros.
Okay. Oh.
And these are factors.
Okay, I see that. So yeah, like the signs kind of flip. Like for the zeros, the 6 positive. On the factors, it's negative. The signs kind of flip.
Yeah, good job. Good job. And if I were to draw this crazy thing on a graph, which, I know you're thinking, oh, please don't add anything else, Miss Sparks. Be negative 1. And what was our original 0? Negative 3?
Yes, ma'am.
That means this graph is going to do something wonky like that. and go through the x-axis on all of those points. It's going to curve up and down and do that. And that's where it's going to cross the x-axis. Okay? That's the whole reason that you find all this stuff. There's a purpose. And your Jake's going, I don't ever want to graph this thing ever in my life, so I'm not sure that that's a great purpose. But anyway, that's kind of the point behind all of that. Okay?
Yes, ma'am.
All right.
Thank you for your help. Yes, ma'am.
You're most welcome, sweetheart. Have a blessed afternoon.
Yes, ma'am. You too.
Bye-bye.